Hi guys, welcome back to part 2 of chapter 4.2 on linear relations. Today we're going to look at different ways we can describe relations. So there are many ways to describe a relation. You may be asked to describe a relation in words, in a picture, in a table, in an equation, or in a graph. So usually a relation will be given to you in one of these situations, and you may be asked to describe it using any of the others. So let's look at an example. In the pattern below, each square has a side length of 1. The perimeter of each rectangle is related to the number of squares. So we have different sets of squares. We have 2 squares, 3 squares, 4, and 5. And we're looking at the number of squares and the perimeter. So in this case, the pattern or the relationship is being described using pictures. So if we look at the first image in the pattern, there are 2 squares and there's a perimeter of 6. So each little line is worth 1. And we're not counting the middle one because remember, perimeter is just the outside edge. So if you count around the outside edge, there are 6 little lines for a perimeter of 6. So in the second one, there are 3 squares for a perimeter of 8, 4 squares for a perimeter of 10, and 5 squares for a perimeter of 12. So this was described using pictures. We're going to describe it in every other way I listed previously. So let's start by talking about it or describing it in words. So remember before, each time we're adding a square, what was happening to the perimeter. In the first diagram, we had a perimeter of 6, and then 8, and then 10, and then 12. So each time we added a square, the perimeter increases by 2. And that would be how we would describe that in words. The next way we can describe it is using a table. So we first have to figure out which is our independent and which is our dependent variable. So remember, we use the sentence, the perimeter depends on the number of squares. And whichever comes first is the dependent variable, and whichever comes second is the independent variable. So when we do our table, we always list our independent variable on the left and our dependent variable on the right. So when there were 2 squares, the perimeter was 6. When there were 3 squares, the perimeter was 8. When there were 4 squares, the perimeter was 10. And when there were 5 squares, the perimeter was 12. So that's how we can describe a pattern using a table. We can describe it using an equation. We're going to use our table to write the equation. So we did that last week. So first we have to figure out how the dependent variable changes. And in this case, it goes up by 2 each time. So then remember, we take that change and we multiply it by the independent variable. But 2 times 2 does not equal 6, so we have to do a little bit of tweaking there. 2 times 2 is 4, and if we add 2 more, we get 6. So let's check. 2 times 3 is 6, plus 2 would give us 8. 2 times 4 is 8, plus 2 would give us 10. 2 times 5 is 10, plus 2 would give us 12. So in this case, our equation is 2 times the number of squares, which is n, plus 2 will give us the perimeter. So we did all that last week, but it's always good to review. But we can describe a pattern using an equation. Finally, we can describe a pattern in a graph. So to graph it, just like I showed you in the video before this, we can use our table of values to help graph it. So we have our graph. We're going to put our independent variable along the bottom, or the x-axis, which in this case is the number of squares. We're going to put our dependent variable, in this case the perimeter, along the y-axis, or the horizontal, or the vertical axis. Apologies. So once we get our axes labeled, we're going to put our numbers on them. So remember, for the number of squares, we have to go up to 5. And for the perimeter, we have to go up to 12. So I just went up by 1s along the bottom, and I went right up to 6, just so I have a little bit of extra space. And with perimeter, since I only have 6 spaces there and I have to get up to 12, I went up by 2s. And then I plot my points. So my first point, number of squares 2, perimeter 6. Then number of squares 3, perimeter 8. Number of squares 4, perimeter 10. And number of squares 5, perimeter 12. I plot my points. The last thing I have to think of when graphing a relation is, does it make sense to connect the points? So let's review that train of thought that we talked about in deciding whether we need to connect the points or not. So we do connect the points when it makes sense that the data exists between the points you've plotted. So for example, time, distance, or price. So if I am talking about time and I have like 1 minute, 2 minutes, 3 minutes, 4 minutes on a graph, well, in between each minute, 1 minute and 2 minutes, there's a minute and a half. There's a minute and 10 seconds. There's a minute and 3 seconds. So stuff does exist between each minute. If I'm talking about time and I'm talking about hours, well, there are minutes in between there. There are seconds in between there. There's all kinds of information in between. If I'm talking about distance and I'm talking about feet, so I have 1 foot, 2 feet, 3 feet, 4 feet. Well, there's inches in between there, so there's data in between. And then price, let's say I go up by dollars, $1, $2, $3, $4. Well, there's cents in between. So for all of those, there's there's information in between the data I'm plotting. So it's what we call continuous data, and you would connect your points and draw a line. When would you not connect your points? When it's weird to have data in between the points. So for example, if you're talking about the number of people somewhere. So if you have 1 person, 2 people, 3 people, 4 people. Well, between 1 person and 2 people, you're not going to have an in-between. You're not going to have a half a person. If I'm building a diagram, if I'm building a structure using linking cubes, and so along the bottom I have 1 cube, 2 cubes, 3 cubes, 4 cubes. I'm not going to have a half a cube or a quarter of a cube. It doesn't make sense. Or maybe I'm doing a problem where I'm ordering t-shirts and I'm comparing the number of t-shirts to the cost. Well, I'm not going to order a half a t-shirt or a quarter of a t-shirt. So it doesn't make sense to have information in between. It's weird. So that's what we call discrete data, and we wouldn't connect the points. So in this case, we wouldn't connect the points because the data is discrete. We're not going to have a half a square or 2.5 squares or 3 1/4 squares. We're just adding a whole square at a time. So we're not going to connect these points. So our graph is done just like that with the dots on it. So those are the different ways we can describe a relation. So you should be able, when given a relation, to describe it a number of different ways.